that you might think about. And here we go. All right, a couple of things that I want to go over about SAT Desmos. All problems that we're working here tonight are problems that we can use Desmos. That's the whole point. But I do need to point out that not all problems that I'm working tonight are going to be optimally solved using Desmos. Oftentimes, problems are much faster and easier to solve by not using Desmos, right? But the point is that if you are working a problem and you're kind of stumped on the algebra or the analytical method to use, you could then say, well, gee, maybe I could do this on Desmos since I can't figure out how to do it. And so then maybe your only option is Desmos because you don't see another way. So I want to just kind of open your eyes to how Desmos might come into play on problems that you really wouldn't consider it to come into play on. Okay, so that's the whole point here. I would say this, that raw numeric calculations where you're just adding, subtracting, multiplying, dividing, probably your handheld calculator, your TI-30, your TI-84 is probably going to be your best bet, although Desmos can also be used as a regular calculator where you put an expression in to calculate some sort of a mathematical expression. I have kind of decided, as I've worked with students over the last year on this digital platform, is that really you probably should be using Desmos exclusively and not your TI-84. But definitely take your calculator with you. But all of those calculations could be done on Desmos rather than the TI-84. One exception to that is fractions, right? Your TI-84 and your TI-30 will do fraction math for you, but Desmos does it even easier. So I'll try to remember to show that to you. One of the things that you want to do is be sure to practice the keystrokes of Desmos before the test, right? Because there are some shortcuts that you need to know. I'll show you some of those as we go, but definitely try using Desmos with some of the problems we're working tonight, and then and get used to using it, okay? So that when you go in on test day, it's not like this weird thing that you're trying to learn as you go. The problems that I am working tonight are going to be posted in the chat in PDF format. So I will do that right at the end here, and I'll tell you when I post those so you can grab them if you want and work on them later. Now, if you don't know already, Desmos is the calculator that's embedded in Blue Book. So when you do your test on test day in Blue Book, you'll have a calculator link in the upper right-hand corner, and it'll open up Desmos in a left-hand pane. So you can always keep it open on the math portion. And I recommend keep it open, have it right there ready to go. And on the right pane, you'll be seeing your questions. Maximize Blue Book on the device that you're using, so you use maximum space on your screen, and then you can keep Desmos open. As you're practicing Desmos, though, you can just go to desmos.com/calculator, and there it is. You'll see it. So it's a website, right? So you can use it. It's the exact same platform. It's the same calculator. The only difference is in the Blue Book version, you can't upload pictures or other things, right? So, but other than that, it's the exact same thing. So let's go ahead and get started. And again, if you're just joining or if you've fast forwarded to this point, my name is Mr. Rich. I am a math tutor here in Jacksonville. I do work with Ms. Bedard's Sort of Success students, and that's who this seminar is for, to help you get ready for this upcoming December 7th SAT. I'm going to pull up my screen and we'll take a look at Desmos and the problems that we're going to work on tonight so I can demonstrate to you some of the ways Desmos is going to work for you. And again, any questions, post them over into the chat. All right, Connor, can you see my screen okay?
Yeah, I can.
Okay, very good. Thank you. Okay, so here's the problems we're going to work. I've got this, I think there's about 31 problems. Probably won't get to all of them, but, and those are the answers. So here's the problems. So I've got Desmos open up here in my right-hand pane. All right, so here's the first problem that I want to show you. This says, what is the positive solution to the given equation? Well, it's a quadratic, and you would solve this by graphing. But if it's a single variable equation and you want to graph it, what you can do is graph the left-hand side of the equation and graph the right-hand side of the equation and see where they intersect. So I'm going to come over here in Desmos, and type y equals, I'm going to use x instead of z. I'm going to do x squared plus 10x minus 24. That's the left-hand side of the equation. The right-hand side is y equals 0, which is the x-axis. So I didn't really need to graph it since it's the x-axis. And then I can zoom in and out, and I can see that these two lines intersect each other at an x value of 2 and an x value of negative 12, and it wants the positive solution, so my answer is a 2. No algebra. It just required me to find the intersection of the equation on the left side and the one on the right side, and it wanted me to pick the positive answer. So there you go. So that's one way that you can solve an equation. And it doesn't have to be a quadratic, right? It could be this equation here, which is a radical equation. It says, what is the smallest solution to the given equation? Man, I am going straight to Desmos on this. I am going to graph the left-hand side and say y is equal to, now this is a radical, and so if I type the letters SQRT, it pops up a square root. I don't need to go down here into this little button, which is a keyboard within Desmos, right? I don't use that keyboard hardly ever, right? I am using keystrokes, but I am going to put x minus 2 raised to the second power. That's that's the left-hand side. The right-hand side is y equals the square root of 3x plus 34. And there we go. So they're intersecting at these 2 points. Now, when you are solving an equation, a single variable equation by graphing left and right, you look at those intersection points, you are not at all interested in the y coordinates. They are the x coordinates that are the solutions. So there's a -3 solution and there's a 10 solution. It wants the smallest. Well, -3 happens to be the smallest between -3 and 10. There's my answer, right? I just saved myself a bunch of time and not having to do algebra for that problem. All right, let's go to the next one. This says the solution to the given system of equations is x, y. What is the value of x minus y? Now, I apologize, these didn't wrap around, but those are the 2 equations. So I can solve a system of equations by doing basically what I was doing for the single variable equations. I'm going to graph both of the equations and see where they intersect one another. So I will clear out those equations and type in y equals 4x plus 1 and 4y equals 15x minus 8. All right, now it looks like they're almost parallel, but it does look like they're intersecting eventually. All right, and if you zoom in where it looks like, if you start clicking and moving your mouse around, that gray dot shows up. It knows what I was looking for. There it is. So the solution to this system of equations is -12, -47, and it wants me to subtract them. -12 minus a -47. Well, I'll even do that in Desmos so I don't make any mistakes. I'm going to do -12 minus -47, and it yields an answer of 35. That's my answer. All right, very good. Let's keep going. In the given system of equations, A is a constant. Now, I think the couple of students that are here, you are in AP Math, and you know that College Board loves to put in missing coefficients. And it's no different on the SAT than it is in AP Pre-Calc or AP Calc. Here we have a system, and A is a hidden constant. It says the graphs of the equations intersect at exactly 1 point in the XY plane. What is the value of X? Man, this is a quadratic. Okay, so here's what we're going to do. I'm going to use Desmos on this. I'm going to graph the parabola y equals 2x squared minus 21x. Now, I'm going to talk about the keystrokes that I just did there. I'm so used to it, I don't even think about it. But when I do, also, by the way, if you've used Delta Math, the keystrokes are very, very similar, if not identical. When I want to make an exponent, I am using Shift-6 on my keyboard. It raises a superscript. I put a 2, and then I hit the right arrow on my keyboard, and it goes out of the exponent. And then I keep typing 21x plus 64. That's a parabola. If I zoom out, I can see the parabola. Now what I'm going to do here, students, is I'm going to graph y equals 3x, and I'm going to actually put in the missing coefficient as an a. And what Desmos does, if you've never used Desmos before, you may not know this. If you have, you've seen this, that it asks you, hey, do you want to add a slider so that you could change that constant? And I'm going to add a slider. I'm going to zoom in and see what's happening. This slider allows me to change the a value. And it says that this system is supposed to intersect at exactly 1 point. Right now, with a equals 1.4, it's intersecting at 2 points. As I slide this around, it looks like I need to move the slider down here. And I'm going to zoom in and try to get this a value so that it only hits at exactly 1 point. Now you can see as I move the slider, it has now moved too far. So I'm coming back this way. It looks like -8 is the value. Now, if you're trying values, you can type in your own value. You can put in a -8 and change it to a 0.1. You can see it bounced off right there. It's now no longer connected. But if it's -8, it looks like it intersects at 1 point. And if it, let's see if it shows me where that point is. Okay, notice what happened here, students. It didn't show me that intersection point till I zoomed in far enough, and then it knew to make a gray dot right there. So I now have hit it. I found the a value that makes them intersect at 1 point. Notice though, the answer is not asking me what is a, it says what is x. -8 is the a that made them cross at 1 point, but the x value where they touch is 6. C is my answer. Now, we just saved ourselves. I know I've been talking about this, and this took us maybe 5 minutes. You'll do this much faster, hopefully, but you are avoiding having to even think about what algebra to do on this problem. Moving forward, number 6, you're buying apples and bananas, but you only have $15 and you must buy at least 6 fruit. Apples cost $3 and bananas cost $1.50. And then they do you the favor of making the system of inequalities to represent the problem. So A is apples, B is bananas. And it says, what's the maximum number of bananas you can buy? You probably know what I'm going to do here. I am going to graph these values. Now, I am going to use X and Y because it may think that I want to put constants in. So I'm going to put 3x plus 1.5y. Now, on the less than or equal to, all I got to do is do shift comma, and that's the less than. And then at the right after that, hit the equal, and it knows to make it less than or equal to 15. Then I'm going to put in x plus y is greater than or equal to 6. And what Desmos does with inequality equations is it does the shading for you. I have to zoom way out, and I see my system right here. Now, the overlapping shaded region are all the possibilities. Let's make sure I got this right here. Okay, yeah. Now, the shaded region are all the possibilities that I have for combinations of apples and fruits. Right? It's this region right in here where my solutions are. But it wants the maximum number of bananas, which is the y variable. So look at this, students. This would be, I'm going to draw on this so you can see what I'm talking about. My solution has to fall somewhere in here, right? I can't come over here because then I'd be buying negative numbers of apples. Can't buy negative apples. So this point right here is the maximum number of bananas. The answer to this question is 10, and I'm seeing it right on the graph. Remember, solutions to inequalities are regions, shaded regions, and it did the shading for me, and I now know my answer is the number 10. Okay, I hope that is opening your eyes here, class, to some things that you can use Desmos for that you hadn't thought of. Moving on, number 7. This says in the given system of equations, t is a constant. If the system has no solutions, what is the value of t? Now, this is an example of when I'm not using Desmos, and you might think you're going to use Desmos. There's a specific type of systems of equations problem that I don't recommend using Desmos for, and that is a system of equations that has no solution. So instead, and I'm only showing this on the Desmos video here because it's when don't use Desmos, when you might think you're going to use it. Because what you would have to do is graph these, use this a slider for the constant t, and you'd have to look to see where the lines would be parallel. And it is really hard to tell when lines are going to be parallel when you graph them. You just have to trust me. If you want, after this video, try it and see if you can make it work. The way that you would solve this equation, a system of linear equations that has no solutions, is you put them both into y equals mx plus b format, both of them. And then you set their slopes equal to each other, because if the system has no solutions, they must be parallel lines and their slopes have to be the same value. All right, now I'm not going to do that here, but it just takes a few algebra steps to put this into, I will solve this one and put it into y-intercept, because all I have to do on this second equation is divide by t on both sides. And I get 1 is equal to 1 over 2t plus 2 over t times x. So 2 over t is the slope of that second line, and I would set it equal to the slope that I would get when I solved that for y. Okay, let's move on. Number 8. The quadratic function h is defined as shown below. In the xy plane, the graph of h of x intersects the x-axis at points 0 and t0, where t is a constant. What's the value of t? It's asking me to find the x-intercepts here. It's not that hard. This would be one that I might do without Desmos because I know how to do it. But if you're like, I'm not sure how to do this, I think I'll do what Rich said and I'll graph it and see what the value of t might be. So I will graph y equals 2 parentheses x minus 4 squared minus 32. There's my parabola. Sure enough, it does cross the across the x-axis at 0, 0, and then over here at 8. There we go. T is equal to 8. Got it. Okay, let's move forward. Number 9. The graph shows the relationship between the number of shares of stock from company A, X, and the number of shares of stock from company B, Y, that Simone can purchase. What equation would represent this relationship? I would not use Desmos on this. I would put each of these equations into slope-intercept form. But if you're like, I don't know, I'm not sure I know how to do this, what I would do is I would graph each of the answer choices to see when I'm going to get a line that looks like this with a y-intercept of 40 and an x-intercept of 60. And this is why you want to practice Desmos, so you can put these in quickly and efficiently. Okay, it's definitely not A because that graph has a positive slope, so no good. 8x plus 12y equals 480. I don't see it because I probably need to zoom out. Okay, there's a y-intercept of 40. Yep, and does it have an x-intercept? Yep, it does. That's got to be the line I'm looking for. Answer is B. Moving forward. We're not even halfway. Halfway through our time. Number 10. In the xy plane, the graph of this equation intersects the line y equals c at exactly 1 point. What is the value of c? Well, this is another time that College Board is making us work with a missing number. C is a constant. They're just not telling us what it is. It's a missing constant. I am going to graph the parabola. Y equals negative x squared plus 9x minus 100. Right? And so it's way down here. And then I'm going to graph y equals c. Now, thing about this, it is assuming c is a variable. So you have to know in this case, it's not supposed to be a slanted line like this. It's supposed to be y equals c, where c is a constant, should be a horizontal line. What I need to do here is put 0x plus c and then add a slider. All right, that's just a little quirk there. So that's it. So now what I want to do is I want to use my slider and get it down to where it's going to hit that parabola at only 1 point. Well, notice that my slider only goes to negative 10. So, but that's okay. All I got to do is click on that lower limit of the slider and put in like negative 100. And then my slider readjusts, and then I can slide it down there. Now I'm going to zoom in and see what happens. Okay, it's kind of, notice it's kind of, so what I'm going to do here, class, I'm going to go ahead and try my answer choices. I can click up here in C and try negative 481 over 4. I got two negatives. That would not be good. Okay, where's my C? Nope, that's not the answer. I don't think negative 100 is going to do it. Nope. How about negative 319 over 4? That does the trick. I zoom in and I click, it knows that I'm looking for that. It does, it intersects. What's it asking me for? It wants the value of C. C, yep, I got it. That's my answer. The answer for C is C. How about that? Number 11. F of x is 4x squared plus 64x plus 262. The function g is defined by g of x equals f of x plus 5. For what value of x does g of x reach its minimum? This is a problem of function transformation. If you're watching this video, hopefully you know that taking a function and pulling the x out and replacing it with x plus 5 is a horizontal shift to the left 5. But here's the cool thing about Desmos. A lot of students don't know this. If I graph f of x and I want to transform the function, I can tell it to graph f of x plus 5. Okay, and it will give me that. It's the black line. I'm going to look for the black one because that's the one I'm looking for. It did both of them. And you can tell it did. It shifted it over 5. I click on it. Yeah, the minimum, it says at what x value does g of x reach its minimum? That's an x value of negative 13. There's my answer. All right. Now, keep in mind, class, this doesn't mean that when you're taking your SAT on Saturday that it's going to be 10 problems in a row doing Desmos. No, I've selected problems that are all possible to be done on Desmos. It may be one every 4 or 5 questions, but I'm showing you the breadth of the possibilities here that you could use it. All right, let's go down and take a look at maybe some different ones here. Let's move into kind of a different section. Let's take a look at numbers of solutions. Let's look at number 14. There are questions on the SAT where they present an equation and they ask you how many solutions does it have. They're asking me how many distinct real solutions. This is a question, since it's a quadratic, that would require me to calculate b squared minus 4ac. That is the discriminant. If the discriminant is positive, it's got 2 real solutions. If it's 0, it's got 1. If it's negative, it's got none. But if you're like, I don't remember about the discriminant, I don't know. All I can do is graph this. So I'm going to graph the left-hand side, graph the right-hand side, which is the x-axis, y equals 0. They never intersect one another. Therefore, there are no solutions, right? I'm treating this as a system. I'm saying, when will this equal this? And if the two things never touch each other, that means there's no solution to this, 0 real solutions. In the given equation, C is a constant. The equation has no real solutions if C is greater than n. What is the least possible value of n? Well, I'm going to go and graph this with a slider. I'm going to do y equals x squared minus 34x plus c. And I'm going to add a slider. Okay. And then I'm going to zoom out. There's my parabola. Well, there's 2 real solutions right now with c equal to 1, because I can see that it's crossing, right? I would graph y equals 0, right? I'm graphing the right-hand side and the left-hand side. They're intersecting at those 2 points. So that means I got to adjust my c right here. Let's see what it's doing here. Yeah. So I need to go way higher. I'm going to change this to an upper of 200 maybe, and then go to town on this. There we go. So it's coming up. It's coming up. Wow. I got to go higher on the higher end here. Let's go to 300. Oh, wait, I don't want to adjust. I don't want to adjust that. I want this to be 0. Okay. And then I'm moving this up. Okay. So I'm going to zoom in on this, and at 290, it's above. I'm going to back off and go to 289. 289 is where, wow, it's exactly there. So C has to be greater than 200, 289 has to be my answer because it says there will be no real solutions if C is larger than a certain number. Well, that number has to be 289. 289, there's one solution, but as soon as you go a little bit higher, 0.2, 0.2, you can see no solutions now. So 289 is the answer there. How many solutions does this have? Well, I can tell you absolute value problems are kind of a scourge for most students. They really do trip students up. They're hard. They're piecewise functions basically, right? So they look harmless, but what I'm going to do is I'm going to just rely on Desmos to do the trick. So I'm going to do minus the absolute value of x plus 6 as one of the graphs that I'm going to make, and y equals 21 as the other. Absolute value bars on your keyboard, on a standard computer keyboard, would be shift and the key right above your enter key. There is a vertical line. So I'm going to do that and do x plus 6 and then put the other vertical line. And you know that hopefully you know that absolute value functions have that characteristic V shape to them. And then I'm going to do y equals 21. Well, again, these two sides here, they never intersect. So therefore, there's no solutions. The answer to this problem is the number 0. Okay. Now, I would not have done this on Desmos. This is a classic example of where I would divide both sides by a -1. And I know there's no solutions because an absolute value quantity can never be negative. It's always going to be greater than or equal to 0. So that's how I know I would have avoided Desmos on that one. Number 17. That looks like, do I have a duplicate problem? I sure do. That is a duplicate there. Let's go to number 18. The function p is defined by p of n equals 7n to the third. What is the value of n when p of n is equal to 56? Well, hopefully you're familiar enough with fractions to know what it's asking, right? It's wanting us to solve for n when p of n is 56. In other words, we're supposed to set 7n to the third equal to 56. Now, I would use algebra for this, right? I mean, I would divide by 7 and get an 8. And then I know the cube root of 8 is 2. However, if you're like, I'm not sure I know how to do this, then graph it. I will graph y equals 7x to the third. I will graph the right-hand side, which would be a horizontal line, y equals 56. I know it's going to be way up here. I'm looking at where they cross each other. The answer is 2. There it is, the number 2. Next. All right, here we go. This is an interesting problem here. Which expression is equivalent to this? Now, this one is definitely one that if you are scoring in the 600s and you're trying to get to 700s, you need to know the algebra on this, right? But there is a way for me to figure out what this is without algebra. If I didn't know how to do the algebra on this, I would probably skip it and maybe come back if I had time. And if I did have time, here's how I could do it on Desmos. And there's several ways. I'm going to do it this way. I'm going to actually type in this expression, and I'm going to use a for x. And I'll use x. We can use x. It's no big deal. So I'll do 8x minus 7 minus 3x minus 7. Now, I need to put this all over 2x minus 14. And this, again, is why you want to practice with Desmos, because if I just hit slash, it only puts the second part of that. I need to put parentheses around this whole thing so that when I hit slash, it puts that all in the numerator. So 2x minus 14. All right, that is that. Now, what I'm going to do down here, I'm going to let x equals 3. See if that didn't work. What do I want to do here? I think what I'm going to do here, I'm going to change this to an a. I'll show you why. And then I'm going to add a slider. Get rid of that. Because what I'm going to do is I'm going to pick a number for a and put it in there. And it maybe did that for x, I didn't notice. But when a is 4, it tells me this expression is 14.5. Now I'm going to use one like 2 or maybe 3. So if I can get a whole number. I can't really get a whole number. How about 5 or 6? Okay, whatever. We'll stick with 6. Then I'm going to look at the rest of these and see which one would give me 22.5 when x is 6. Well, 6 minus 7 over 5 is not 22.5. I don't know. What about 8x minus 3? Let's do 8. What we'll do here is we'll do 8 times 6 minus 3 all over 2. Whoops, a daisy here. Yikes. Slash 2. 22.5. Okay, well, it turns out it looks like this is going to be my answer because when I plugged a 6 in up here and plugged a 6 into this, it yielded the same result. Okay. The other way that you could do this is you could have graphed this thing and looked to see the graph and actually look at what its shape is or where it is, and then graph each one of these and see which one of these lays right on top of that. Okay, so you could try, it's another way you can do it. The algebra is much easier when you do this because you're supposed to know on this problem to factor out the x minus 7, sorry. You're supposed to know here to factor out x minus 7 on the top. And that gives you x minus 3 times x minus 7. In other words, this is like factoring by grouping. This is 2 times x minus 7. And there you go. That's your answer. But Desmos is not the most efficient by far, but it is a possible way to do it. Now, I'm going to show you another problem here that maybe could best be solved without Desmos, but yet it's one that most students wouldn't know how to use Desmos to do this. Here's what I'm going to do. It tells me which values of A, B, and C in the table below give 3 values of x for the given function. What I'm going to do is I'm going to make a table. So if you hit this plus sign right here, you can put a table in Desmos. And I'm going to put those values in for x, negative x, 0, and 1. And then I'm going to come up here where that y1 is. I'm going to put 2x1 squared. Now notice that this variable is x1. If I don't put a x1 and I just put an x, it doesn't know what I'm talking about. And it also knows that when I hit the number 1 on my keyboard, it makes it a subscript. So I don't need to like go find a subscript key. So I've got 2x1 exponent squared plus 9. Yeah, it filled the table out for me. 11, 9, 11. A is the answer. Okay, students, I hope that you're finding that interesting and helpful. Number 21, the function f is defined by f of x equals 4x. For what value of x does f of x equal 8? I know that this is 2, all right? You would solve this by setting 8 in place of that. However, you could, if you were like, I just don't trust my algebra, you could say, well, I want to do f of x equals 4x. And then I'm going to so I'm treating this like a system of equations. I got f of x equals 4x. Then I'm going to graph f of x equals 8 and then see where they would intersect one another. No surprise, they intersect at an x value of 2. This would be another one. I think I would not use Desmos because I know how to do this problem. But if I didn't and I knew how to use tables, or actually, this is what we call regression. Those of you that have taken AP stats or that have taken or are in AP pre-calc, you understand what regression is. Where you take a table of data and you find the line of best fit that passes through those points. This is saying that there's a table of values and they are a linear function such that f of x equals ax plus b. What's a times b? Well, I can do this. I can make a table of values and do a regression. There's my table. I'm going to do negative 3, 3, and 9. Then I'm going to come up here and do 10, 14, and 18. Then I'm going to come down in the line down here, and I am going to tell Desmos to make an equation of the line that fits those 3 points. Here's how you do it. I'm going to use y1 because that's the variable up here. Y1. Then here's where, if no one shows you this, you would never know that you're supposed to do this. Instead of putting an equal sign, you have to know to use a tilde. Where is the tilde? This is one of the few times I have to go to the Desmos keypad. It's not on the keypad until I hit ABC. There's the tilde down here at the bottom. When I hit the tilde, it puts a tilde there. And all the tilde does is that's the symbol that tells Desmos that I want you to do a regression on this variable y1, and I'm going to say m times x1 plus b. It does it, and it tells me what the m and the b are. It tells me what I would call A and B. Now, if I wanted to, I could probably have even used the same letters and said AX1 plus B. And there's my A and my B. So my answer, I don't even have to take my eyes away from Desmos. I can just say, gee, what's 0.6667 times 12? Oh, 7.999. I'm going to go with the number 8. For whatever reason, they wanted me to multiply the slope and the y-intercept. There's the slope, 0.6667, and there's the intercept, 12. And I got my answer. I would have probably just calculated the slope and used point slope, okay, and gotten the slope and the y-intercept that way. But Desmos can save the day. Now, look, if you don't know how to do this, that would be concerning, right? If you don't know how to match that expression to one of these, that would not be good, okay? But if you're like, man, I'm really bad at algebra, so I'm going to type in this expression y equals 9x squared plus 5x. It's a parabola. I wonder which of these, when I graph it, will be exactly the same graph. So when I try y equals the first one, which is x plus 9x plus 5, I think I found it. You see how it matches it exactly? It turned color. If I turn this one off, it's black. Turn that. Yeah. Okay. But I already knew that because I know how to factor from algebra 1. But again, Desmos could do it. All right, here we go. Again, you should know how to convert rational exponents, fractional exponents, into radicals. But there's a way around this one, right? What you could do if you're like, I don't remember how to do any of this, then pick a value for A. I'll use the number 5, and I'm going to raise it to the 11/12. And that's the answer, 4.372. What I'm going to do is now go and get this radical. Now, this would be another time when I have to use my Desmos keyboard because I want to get a radical where I can put my own root in. Now, there is on the regular keyboard, there is a square root button down here, but I never use square root button because I type SQRT, it makes it for me. However, to get some arbitrary root, I got to go to the keyboard and I got to click on the functions button over here. And there's a bunch of functions. It just so happens that this is at the very bottom of the list under the number theory section. So I click that and I can put the root 12, and my A that I selected was 5. So I put a 5 and raise it to the 132. And I did not get the same answer as I did when I plugged 5 in for A here. No problem. I'm just going to come over here and change this root to a 144. And there I get the match. So now I know I found my answer right there. Man, I'm surprised we might get to the end of this. 25. So now I think the next few problems are dealing with circles. One of the things you do need to know about circles is that the formula sheet doesn't have is the standard form of the equation of a circle. It's good to know this going in, that x minus h squared plus y minus k squared equals r squared is the standard form of a circle equation. But anyways, here they give me this. They don't tell me what the center is. They just tell me that they're constants. And it says the point 827 lies on this circle. Which of the following is a possible value for k? Man, this is a great problem for Desmos. In fact, before Desmos on the SAT, I would have instructed my students to sketch the graph by hand, okay, of the circle. But that's okay. What I'm going to do is I am going to use sliders for h and k equals 144. So I know my radius is going to be 12, right? That's r squared, the 144. All right, there is. Oh, I forgot to square this. No wonder it looked like a parabola. Okay, there we go. So there's my circle. And notice the circle moves around as I change h and k because those are the coordinates of the center. Well, the other thing you can do with Desmos is you can go into one of these lines and have it plot an ordered pair. As long as you don't hit the wrong key. There we go, 827. All right, I'm going to move my slider around. I think, yeah, I want to move my slider around for K, but it's not reaching. So I want to reset this upper step to like 20 maybe, or let's go to 30. So there's my new slider. Okay. So which one of these values? I'm at K equals 20. If my K was -8, that definitely isn't going to work. It's not even close to that point. If it's at 12, it's not quite there. If I go to 39, I'm just going to type in 39. Could K be 39? Maybe. Does that slide over and hit it? See, if K is 39, H could be a number using my slider that would hit the point right there. That's my answer, 39. And you say, well, what about 43? I don't know. Let's try 43. Yeah, the problem with 43 is that no matter what H value I would select, it's going to miss that point. There you go. So we just avoided some math and algebra to nail that problem there. Number 26, another circle. There's a circle equation. The graph of the equation is a circle. Yep, I knew that. The point AB lies on the circle. Which of the following is a possible value of A? Well, I could do this without Desmos. I don't have time to show you how I would do it, but I'm just going to use Desmos to make the circle. X plus 4 squared plus y minus 19 squared equals 121. There it is. Well, that's interesting. The point AB lies on the circle. That's an X value. Well, if I click on this circle, it looks like it goes as far as -15 on the X-axis and as far as 7. So it looks like all the X values have to be somewhere between -15 and 719. And by the way, I know what the center is, right? I could plot that point to help me. I could do -4 comma +19. There's my center. Okay. And I could even then, if I wanted to help myself out, do a horizontal line at y equals 19. There's my diameter. So the X values go from 7 back to -15. That's the only number that's between -15 and +7. That's my answer. No algebra, just graphing it on Desmos. Next, let's talk about some statistics problems here. All right, I'm just going to cover this briefly. You probably know how to find medians. It's the middle number, but you know what? Maybe you forgot. Well, if you type the word median, notice it goes from italics to, I don't know what you would call that, not italics, which means it's a command. So if you put median followed by a parentheses, you can list all your numbers with commas separated and it'll find the median, right? I'm not going to do all of this, but if I typed them in, you can see it tells me the median of those three numbers is 74. I'm just going to show you can use the mean as well. And of course, you can use your TI-84 and add the numbers and divide by the number of numbers, or you go to Desmos, type the word mean, put all the numbers in, separated by parentheses, and it'll calculate the mean for you. All right, that's all I want to do there. I do want to talk about number 30 in these last few minutes, and maybe we can get to 31. A model estimates that at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than the number of squirrels in the population at the end of the previous year. The model estimates that at the end of 2016, there were 180 squirrels. So on my scratch paper, I might jot down, that has to be true. Okay. Which of the following equations represents this model where n is the estimated number of squirrels in the population t years after the end of 2015, where t is less than or equal to 5? Well, that allows me to come back here and say, well, you mean when t is 1, I have to get an answer of 180 squirrels. That's because 2016 is 1 year after that. So they've told me one specific point that has to be a solution to this exponential equation. But here's what I want to remind you about. It seems that since they went digital, they've been doing a little bit more of making you think about percentages because they give you percentages that are more than 100%. I want to show you the difference between saying 150% more that there was in 2015-20, the number of squirrels in a population was 150% more than the number of squirrels at the end of the previous year. There's a difference between saying 150% more than and 150% of. Both of those 150% of. Both of those statements will cause an increase in the number of squirrels. If I told you that this year there's 150% more than last year, or I told you there's 150% of the number this year, both of them are an increase. However, when we say 150% more than, that means that we have the original 100% and then we're tacking on 150% more. That's 250% of what there was. So that means you are not going with those two answers right there. And most students, I'm going to say, I don't know this for a fact, but I'm going to guess that probably more than half of students, when they see this, they're seeing 150% and they're going, yeah, I remember that. That's supposed to be 1.5. Yeah, if it was 150% of the number. No, more than, it's 2.5 is my multiplier. Okay, so now to differentiate between these two answers that I'm going to choose from, I know that when t is 1, I have to get 180 squirrels. Well, down here, when t is equal to 1, that's not going to give me 180 squirrels. Because if I do 180, oh boy, if I do 180 times 2.5 to the 1, that's 450 squirrels. No, B is my answer. 72 times 2.5 raised to the 1 power gives me the number of squirrels they told me they were supposed to be in 2016. Okay. If they had told me that this 180 squirrels was what they had in 2015, not 2016, yeah, it would have been that answer. But there is my answer right there. Well, students, I hope the video was helpful to you in learning how to use Desmos to solve some SAT math problems. I wish you all the best of luck if you are taking the SAT tomorrow. And be sure to follow me on YouTube. And I do post videos weekly. And be sure to check me out.